1.1.1, we have x squared plus 2x minus 15 is equals to 0. So now the question I ask myself is, which two numbers do I multiply and they give me minus 15, but when I add them they give me 2? Clearly that is minus 3 and 5, right? So as the result, I'm gonna have x plus 5 multiplied by x minus 3 is equals to 0. So x plus 5 is equals to 0, or x minus 3 is equals to 0. So x is equals to minus 5, or x is equals to 3. And then now we can move ahead and do 1.1.2, which says 5x squared minus x minus 9 is equals to 0. Leave your answer correct to 2 decimal places. As soon as I see an equation that has a coefficient here of x squared not being 1, I know I'm going to use the quadratic formula. Whether the question asks me to leave it in 2 decimal places or not, I'm just going to use the quadratic formula because I don't want to give myself problems. So what I'm going to do here, I'm going to say x equals to minus b plus or minus b squared minus 4ac divided by 2a. So what is minus b? We know fully well that minus b will be minus 1, right? So as a result, we're going to have plus 1 here, plus or minus b squared. So we have in minus 1 squared, so it will just be 1, minus 4 multiplied by 5 multiplied by minus 9 divided, everything divided by 2a, right? Oh, again, a is 5, right? So I'm going to have 5 here instead, which will just give us 10. So we're going to have x equals to 1 plus or minus, let me put all that which is inside the square root in my calculator, right? So I have 1 minus 4 multiplied by 5 multiplied by minus 9. So that is giving me 181 divided by 10. So now I can tell that x is equals to 1 plus the square root of 181 divided by 10, or x is equals to 1 minus the square root of 181 divided by 10. So x will be equals to, again, just run into my calculator and putting it in, I'm getting 1.4454, or x being equals to minus 1.2454, and then you get your marks. And now 1.1.36 x squared is less or equals to 3x. So I'm gonna subtract 3x from both sides, and then I'm gonna get x squared minus 3x is less or equals to 0, right? So now I want my critical values, right? So I'm gonna say x squared minus 3x is equals to 0. So if I pull out x, I get x minus 3 is equals to 0. So x equals to 0, or x equals to 3. So now when I have these two critical values, there's only two possible solutions, right? One solution is that x is greater than 3 and x is less than 0. That's the first possible solution. The other solution is that x is between 0 and 3. So how do I know which one between these two is the correct one? I take a number in this range between 0 and 3, right? If it satisfies this equation here that we are solving, then that solution will be correct. So for instance, between 0 and 3 I have 2, right? So let me just take 2. So if I plug in 2 here, I'm gonna get 2 squared, right? Which will be 4, which is supposed to be less or equals to 3 multiplied by 2 is 6. So this is correct. So as soon as this is correct, we know that this is our right solution. This one is wrong, and yeah, so we can move forward. So we have 1.2 and then 1.2.1 we're solving for a, and we given a plus 64 divided by a equals to 16. So I don't like dealing with fractions, they're so complicated, so I'm just gonna multiply everything with a, right? So I'm gonna get a squared plus 64a equals to 16a. So if I take 16a, actually this is just supposed to be 64 and not 64a because it's been divided by a, my bad. So we're gonna have a squared minus 16a plus 64 equals to 0. So now I have to factorize this, right? Which two numbers do I multiply? I get 64, but when I add, I get minus 16. That's minus 8 and minus 8. So I'm gonna get a minus 8 multiplied by a minus 8 equals to 0. So a equals to 8 basically, because I'll be repeating myself if I say or a equals to 8 again. So a is just equals to 8. And then we have 1.2.2 that says hence solve for x if 2 to the power of x plus 2 to the power of 6 minus x equals to 16. So here, because it says hence, I'm looking at 1.2.1 and trying to apply the same idea I use. Like, what are the similarities between 1.2.1 and 1.2.2, right? Obviously, you can solve it independently of 1.2.1, but I think it will be more challenging compared to if you just apply the same ideas from 1.2.1. So what I realized here in 1.2.2 is that I can write it the same way I wrote 1.2.1. So I can let a basically be 2x, right? So if I let a be 2x, you realize that we'll have 2x plus 2 to the power of 6 divided by 2x equals to 16, right? And then if you solve this, and you make it linear, right, this is what you get. So these two things are equal, so we can now solve from here. But then from 1.2.1, we know that if this is a, if this term here is a and this term here is a, then a is supposed to be 8, because 2 to the power of 6 is the same as 64, right? So now we can say that 2 to the power of x is equals to 8, because when we have these and in place of 2x we have a is supposed to be equals to 8, right? So we're gonna say 2 to the power of x is equals to 8, right? So 2 to the power of x is equals to 2 to the power of 3, because now if we write 8 with a base of 2, we're gonna be able to drop the base and equate the exponents, right? So from here we can see that x is equals to 3, and then we have solved the 1.2.2. And then we have 1.3, which says without using a calculator, calculate the value of, and we have this expression here that looks scary. So one thing I'm not gonna do is not use a calculator. When a question comes and then it says don't use the calculator and it's like this, I'm gonna use a calculator so that I can see what the answer is supposed to be like. So yeah, when I use the calculator, I get 4, right? So I know that my answer is supposed to be 4. So now I can sort of solve the equation, but I already have a heads on. I know what I'm supposed to get, right? So I'm gonna say, let me just write this expression. So we have 2 to the power 1002 plus 2 to the power 1006 divided by 17 multiplied by 2 to the power 998. So here I'm trying to simplify it, right? I'm trying to get rid of the big numbers. So the first thing I realized when I look at this problem is that if I can take out 2 to the power of 998 on this term and this term as a common factor, then I can I can cancel it with this 2 to the power of 998 in the denominator, right? So let me show you what I'm talking about. So this will be equals to the square root of 2 to the power of 998. So I'm taking it as a common factor, right? Or on the exponents. So here I'm gonna have from 2 to the power 1002. If we take 2 to the power 998, we get 2 to the power 4, right? Plus, and then 2 to the power 1006. That will be 2 to the power of 8. So we're gonna get 2 to the power of 8 divided by 17 multiplied by 2 to the power 998. So 998, 2 to the power 998, and then they're gone. So now all I have is just let me write it down. I have 2 to the power of 4 plus 2 to the power of 8 divided by 17, right? And then I know that in the back of my head that this is supposed to give me 4. But then 17 is a prime number, right? It's only divisible by itself and 1. So there isn't much you can do to 17. So we know now, because we have 17 and we cannot do much to it, we know that in the denominator, after we take the square root, right, we're supposed to have 4 multiplied by the square root of 17. So that the square root of 17 in the denominator will cancel with the square root of 17 in the numerator, and we're left with 4. So let's see what we have. So we have the square root, right? So 2 to the 4 is 16, right? And then 2 to the 8 is 256, right? Divided by 17. So this will be equals to 272 divided by 17. So now, because I'm basically cheating. Now I'm gonna say this is equals to 4 multiplied by the square root of 17 divided by the square root of 17. So the square root of 17 will cancel out with the square root of 17, and I'm just gonna be left with 4. And then yeah, we're done. And then now for 1.4, we have 2x minus y equals to 2, and 1 divided by x minus 3y equals to 1, and we're supposed to solve simultaneously, right? So this one here looks pretty much simple compared to the other one. So we're gonna start with this one. So we're gonna have so we're gonna have minus y equals to 2 minus 2x. So we're gonna have y equals to 2x minus 2, and then we can then sub in 2x minus 2 on this expression here, right? On this equation. It's not an expression, it's an equation. So we're gonna have 1 divided by x minus 3 multiplied by 2x minus 2 equals to 1. So I'm gonna have 1 divided by x minus 6x plus 6 equals to 1. So I'm gonna multiply everything with x because I don't like dealing with fractions, right? So I'm gonna get 1 minus 6x squared plus 6x equals to x. So I'm gonna have minus 6x squared plus 5x, right, plus 1 equals to 0. So I'm gonna multiply everything with minus 1 so that I can get 6x squared minus 5x minus 1 equals to 0. I'm multiplying everything with minus 1 because I'm just not used to solving for x when I have a minus on the coefficient of x squared. So if I can get rid of it, I'll get rid of it and make my life easier. So here I'm gonna have 6x multiplied by x is equals to 0, right? This is a bit more tricky. Usually I'd advise people to use the quadratic formula, but then I can try like reason it out, right? Because the only factors of 1 is 1 and 1, right? So you need to put plus 1 somewhere and minus 1 somewhere, and then you put them in a way that the middle term will be minus 5. So if I put minus 1 here, then let's say I put minus 1 here, then 6x and minus 1 will be minus 6x, and then plus x, it will be minus 5x, right? So that sort of satisfies what I'm looking for. So here I'm gonna have plus 1. So 6x plus 1 equals to 0, or x minus 1 equals to 0. So x equals to minus 1 divided by 6, or x equals to 1. So when x is equals to minus 1 divided by 6, what is the corresponding value of y, right? So now we can come to this equation here and substitute minus 1 divided by 6 in place of x, right? So when I have 2 multiplied by minus 1 divided by 6 minus 2, which is giving me y equals to minus 7 divided by 3, right? So here I have minus 7 divided by 3, or we have our y being equals to, now I'm just putting 1, so 2 by 1, that's 2, minus 2, that's 0, right? So I have 0 here. We have our function g of x, which is equals to a multiplied by 1 divided by 3 to the power x plus 7. And then we are told that it passes through some point E, which is made out of coordinates minus 2 and 10. And then the first question, 4.1, says calculate the value of a. This will be relatively easy because we only have one information, if I can say so, which is the coordinate. So we have to use that coordinate to calculate the value of a. So we're gonna say y equals to a multiplied by 1 divided by 3 to the x plus 7, and then we substitute e, right? So we're gonna say sub e. So we're gonna have 10 equals to a to the power a multiplied by 1 divided by 3, not to the power, and then we can have to the power minus 2, which is the value of x, right? Plus 7. So if we solve for a, we're gonna get a equals to 10 minus 7, right? So I took 7 to the left hand side, and then I can divide by 1 divided by 3 to the minus 2. And then if you put this in your calculator, you're gonna get a equals to 1 divided by 3. So now we know that g of x is equals to 1 divided by 3 multiplied by 1 divided by 3 to the x plus 7. And then we can move to 4.2. 4.2 says calculate the coordinates of the y-intercepts of g. As soon as I hear y-intercept, I'm thinking x equals to 0. If it had said x-intercept, I was going to be thinking y equals to 0. So we're going to have y equals to 1 divided by 3 multiplied by 1 divided by 3 to the power 0, because x is 0 at the y-intercept plus 7, which is equals to 1 divided by 3 multiplied by 1, because every number to the power 0 is 1, plus 7, right? So, okay, if you put this in your calculator, you can just get 22 divided by 3. I was tempted to just do it in my head. But anyway, let's carry on. 4.3.1. So we are given h of x, which is equals to 1 divided by 3 to the power x. And then now 4.3.1 says describe the translation from g to h. All right, so let's look at h of x and then compare it to g of x. So g of x is 1 divided by 3 multiplied by 1 divided by 3 to the x plus 7, right? So in order to tell what transformation is going on, you have to write one function as close as possible as the other. For h of x, it's really blank, right? There isn't much we can do. But then for g of x, we can say instead of having 1 divided by 3's, we can see 1 divided by 3 to the power x plus 1, right? and then we'll have that plus 7 there, because if you multiply in numbers of the same base, you can add the exponents. So now we have it as close to h of x as possible, right? And we can describe the translation. This will tell us that h of x equals to f of x minus 1 minus 7, right? This minus 7 here, it tells us that g of x was moved 7 units down, right? 7 units down in attempt to get h of x. And then here, because we have x minus 1, we know that if we have x plus let's say we have x plus q, right? If q is a positive number, then you move the graph to the left, and then if q is a negative number, you move the graph to the right. So because here we have x minus 1, that will mean that this graph was moved 1 unit to the right, and that's how you describe that translation. And now 4.3.2 determine the equation of the inverse of h in the form y equals to. So as soon as I hear inverse, I'm thinking swap x and y and then solve for y. So if I do that, I'm gonna get y equals to 1 divided by 3 to the x, and then if I swap x and y, I'm gonna get x equals to 1 divided by 3 to the y. Take logs on both sides. I'm gonna get log of x is equals to y log of 1 divided by 3. If you take log, you can bring down the y. So I'm gonna get y equals to log of x divided by log of 1 divided by 3, which is gonna give me log of x base 1 divided by 3. So question 5, May, June 2022. It is saying that g of x is equals to a divided by x plus p plus q, right? And then we are told that the domain is an element of any real number except minus 2, and then we're given the x-intercept and the y-intercept. And then 5.1 says show that the equation of g is given by g of x equals to minus 3 divided by x plus 2 plus 1. Okay, on the equation we're given, you have to realize that we have 3 variables. We have a, p, and q. But then the beauty is that we also have 3 information, if I can say so, that we are given. We are given the domain, we are given the x-intercept, and then we are given the y-intercept. And like I always say, if you have 2 variables, you will need 2 equations. If you have 3 variables, you will need 3 equations. And that's exactly what we have here. So yeah. To start, the first thing I'm going to start with is to determine p. Because we know that x plus p is equal to 0 if x is the vertical asymptote, right? Vertical asymptote. We know that this is true, because if it is equal to 0, then you cannot divide any number by 0, then it will be undefined, right? And that only happens at the asymptote. So what is the value of x at the asymptote? The value of x at the asymptote is minus 2. So we're gonna say minus 2 plus p is equals to 0. Why are we saying it's minus 2? We're saying it's minus 2 because our domain is everywhere else except at minus 2. So our graph cannot touch x equals to minus 2. So if we solve p from this, we're gonna get p equals to 2, right? So now we know that g of x is equals to a divided by x plus p. P, we just say that it's 2. So instead of writing p, I'm just gonna write 2 plus q. So now we have determined one variable. We are left with 2, and we have used one equation, if I can say so, which is that from the domain, right? So now we have to use the x-intercept and the y-intercept to find a and q, because that's basically what we have left. So we can say x-intercept, and then we are told that at the x-intercept is some coordinate k of variable of coordinates 1 and 0, right? So the y is 0, so we're gonna say 0 equals to a divided by the x is 1, so we're gonna have 1 plus 2 plus q, which is gonna give us 0 equals to a divided by 3 plus q. I don't like dealing with fractions, they're just too much, so I'm gonna multiply everything by 3 so that I can have a nice equation, if so I can say. So we're gonna have 0 multiplied by 3, which is 0, and then a divided by 3 multiplied by 3, that is a, and then plus 3q, and then this looks better. It's not like a divided by 3, which is just gonna be messy. So I can make a the subject to the formula, or I can make 3q, but then I'm gonna make a the subject to the formula, because if I make 3q the subject of the formula, then I'll have to end up dividing by 3 and I'll get a fraction, and I don't want fraction in my life. They just complicate things. So I'm gonna say a equals to minus 3q, and then I can name this equation 1, because there's nothing else I can do here. I can name it equation 1, and then I can go and use the other point and see if I can solve them simultaneously. Of course, I'm going to be able to solve them simultaneously, because I know that this is what these kind of questions are requiring of me. So the other point we have is the y-intercept, which is some point n of coordinates 0 for the x and minus 1 over 2 for the y. So if I substitute it into g of x, I'm going to get so this is x and then this is y, so I'm gonna get minus 1 over 2 is equals to a divided by, we know the value of p, we see that p is 2, so x is 0, right? So because that's the y-intercept, so we're gonna have 0 plus the value of p, which is 2, and then plus q. So here we're gonna have minus half equals to a divided by 2 plus q. Again, I have fractions and I don't want fractions in my life, and then I can see that if I multiply by 2 I can solve that problem. So I'm just going to multiply everything by 2. I'm going to get minus 1 which is equals to a plus 2q, and then this is equation 2, right? So I can substitute a here, and then the only variable I'll have is q, and then I can solve for q and then go back and solve for a. So I'm gonna sub equation 1 into equation 2. So I'm gonna have minus 1 equals to a, we say that is minus 3q, and then plus 2q, which is gonna say minus 1 equals to minus q, so q equals to 1, and that's what we're supposed to get because of the equation we're given. So now that I've found the value of q, I can use this equation 1 here to find the value of a. So I'm gonna say a equals to minus 3q, right? And then I know that q is 1, so a is equals to minus 3, and that's exactly what we are given. So from this I know that g of x is equals to minus 3 divided by x plus 2 plus 1. I've determined q, I've determined p, I've determined a, and I get my 6 marks. And then 5.2 says determine the range of g. G is a hyperbola, obviously. So we know that for hyperbola, in our standard format, the range will always be y being the element of r but then y cannot be q, right? Q being 1 in this instance, so y cannot be equals to 1, right? Because for y to be equals to 1, we need x to be equals to minus 2. And if x is equals to minus 2, then our equation is undefined, because you cannot divide any number by 0. Because look, if we say g equals to, let's say we have a, and then we divide by minus 2 plus 2 plus q, which is 1, right? This part here is gonna give us undefined. So for g to be 1, we need to say undefined is defined, and that's not correct. So y can never be equals to 1 because of what we just talked about. And then moving to 5.3, if you want to know how to calculate the domain, I've done so many videos in hyperbolic functions. Go on the channel, check them out. And then 5.3 says determine the equation of h, the axis of symmetry of g, in the form y equals to mx plus c, where m is greater than 0. So when we talk about the axis of symmetry of a hyperbolic function, there's only two possible scenarios. Your axis of symmetry will be y equals to minus x plus c, or y equals to x plus c. These are the only two possible scenarios. So we are told that m is greater than 0. So here m is definitely minus 1, the gradient, but here it's 1, and 1 is greater than 0. So this is the axis of symmetry we're interested in. So if you can see, the only thing we really need to determine is the value of c. Now the question becomes, which coordinate do we substitute to determine the equation of the value of c? You substitute where the asymptotes meet. So we know that, so let's say some point asymptote. So we know that the vertical, which is the x, counterintuitively so, is minus 2, and the y is 1, which is the horizontal asymptote. So if we substitute where the asymptotes meet, then we can determine the value of c of the axis of symmetry. That is because the axis of symmetry is gonna pass through where the asymptotes meet. So from here, we can say that y is 1, so because this is x and this is y, so we can say 1 equals to x. X is minus 2, so minus 2 plus c, and then we can take we can add minus 2 to both sides. We're gonna get 3 equals to c. So now we know that the equation of our axis of symmetry of m greater than 0 is given by y equals to x plus 3. 4 says write down the coordinates of k, the image of k reflected over h. Usually the way people want to solve this problem, they want to draw it graphically. Go 10 units to the left, go 10 units up, and all that kind of stuff. But then I want to propose a algebraic way. We're just going to use equations because I don't like working with fractions and I don't like working graphically. I want to solve equations which are very linear, straightforward, and easy to solve. So that's what we're gonna do here. So we know that we have some axis of symmetry that is positive, so it's going up, right? And then we have our point k, and then we're supposed to determine k with that notation on top. Okay, so we're just gonna call this k here k subscribe, because you all need to subscribe to the channel. So let's call it subscribe. So we have k subscribe and k subscribe in the reflection of k over our axis of symmetry, right? But then if we draw a line here from k subscribe to k, and we determine the equation of this line, then we can find k subscribe using the midpoint formula or theorem, so to say. So how do we determine the equation of this line that is touching K, subscribing K? Because this line cuts perpendicularly to our axis of symmetry, we know that the equation for the axis of symmetry is x equals to x plus 3, right? So m is equals to 1. So to find the gradient of this line, we're gonna say 1 multiplied by the gradient of our y subscribed equals to minus 1, right? Because they are perpendicular. So the gradient of our line y subscribed will be equals to minus 1 divided by 1, which is just minus 1. So we know that our equation for y subscribed is y subscribed equals to minus x plus c. Now how can we determine c? We know the coordinates of k to be 1 and 0, right? So we can say 0 is equals to minus 1 plus c, so c is equals to 1. So our equation for y subscribed will be equals to minus x plus 1. So now what we're gonna do, we're gonna equate y subscribed and y, the axis of symmetry, right, which is also h of x. If we equate the two, then we're gonna find where they touch, and where they touch is the midpoint between k and k subscribed. So that will be minus x plus 1, which is equals to x plus 3. So minus 2x is equals to 2. So x is equals to minus 1, right? So these two lines, they touch at x equals to minus 1. But what is the y value? The y value will be equals to, we take any between these two equations to find the y value, right? So let's take x plus 3. We're gonna get minus 1 plus 3, which is equals to 2. So the midpoint of y subscribed will be so let's say midpoint will be minus 1 and 2. So now we can find the coordinates of k using the midpoint. So we're gonna say minus 1 is equals to x of k plus x of k subscribed divided by 2. If we cross multiply, we're gonna get minus 2 is equals to x of k is 1, right, plus x of k subscribed. So x of k subscribed is equals to minus 3, right? So we're gonna say y of midpoint, which is 2, is equals to y of k subscribed plus y of k divided by 2, and then we're going to cross multiply. So we're going to get 4 equals to y of k subscribed plus y of k, which is 0. So y of k subscribed equals to 4. So the value of the coordinates of k subscribed will there be 4, will there be minus 3 and 4. Whoa, that's a lot, and you've probably forgotten the steps you have to follow. So step 1, find y perpendicular, right? The equation of y perpendicular, being perpendicular to the equation of the reflection, right? So let's say equation of reflection, of the line of the reflection. And then after you find that y perpendicular, you're going to use the point that lie on y perpendicular to find c, and then you can find the equation. After you do that, then equate y and y perpendicular to find the midpoint, right? And after you've determined the midpoint, you can then use the formula for the midpoint to find the point of reflection, like we just did. So we are told that the sketch below is for a graph f of x is equals to minus x squared minus 6x plus 7. And then C is the y-intercept of f, A and B are the x-intercepts of f, and then D is some point on f. And then 6.1 says calculate the coordinates of E, the turning point of f. Relatively easy. We know that the x of TP, turning point, is equals to minus B divided by 2A, right? So from my equation, we know that A will be minus 1, and then B will be minus 6, and then C will be 7. So minus B will be minus 6, and then A is minus 1, right? So we're gonna have minus 1 there. So x of TP will be equals to 6 divided by minus 2, which is equals to minus 3. And then that makes sense because x of TP it's on the negative x, right? Because that's where E is situated. So we're gonna have f of minus 3 is equals to minus 3 squared minus 6 multiplied by minus 3 plus 7. So I'm just gonna put that in my calculator and get the answer so that we don't waste our precious time. So we have minus 3 squared minus 6 multiplied by minus 3 plus 7, which is equals to 16. So the coordinates of E is minus 3 and 16. And then 6.2 says determine the value of K. K is the Y value of D, right? Because D is minus 5 and K, this is our X, this is our Y. So we're gonna substitute minus 5 into f of x. So we're gonna have f of minus 5 is equals to minus 5 squared minus 6 multiplied by minus 5 plus 7, and we are expecting that value of K to be less than 16, maybe around 15 or 14, because it's just slightly below E. So if I put that in my calculator, it is giving me 12, which is not too far away from 16, but I was not right also. So we have f of minus 5 is equals to 12. So K is equals to 12, right? And then our coordinate D is made out of minus 5 and 12. And then 6.3 says determine the equation of the straight line passing through C and D. So fine, let's make it relatively easy. We know that the coordinate of D is minus 5 and 12, right? And then the coordinates of C, C is a y-intercept, it's 0 and some y, right? So let's calculate the y value of C so that we can use the gradient of CD to calculate the line that passes through. So we're gonna say y-intercept x equals to 0, right? So we're gonna have y equals to minus 0 squared minus 6 multiplied by 0 plus 7. So we have y equals to 0 plus 7. So C is just basically 0 and 7, right? So we can calculate the gradient from there. So we know that the gradient is equals to y2 minus y1 divided by x2 minus x1. So which point are we choosing as point 2 and which point are we choosing as point 1? So let's just take D to be point 2, right? So this will be x2, this will be y2, this will be x1, this will be y1. So we're gonna have 12 minus 7 divided by minus 5 minus 0. So we have 5 divided by minus 5, which is equals to minus 1. So up to so far, we know that y equals to mx plus c, but m is equals to minus 1, so we have minus x plus c. plus c. Now what we are left with is to determine the value of c, right? So we can choose either point c and d. So let's choose c, because c it has all positive values, so it's easy to navigate through c compared to d. So the y is 7, which is equals to minus x is 0, and then plus c. So c is just basically 7, which makes sense because the y-intercept of the line that is passing through through c and d will be the same y-intercept of our graph of fx, right? So we're gonna have y equals to minus x plus 7, which makes a bit of sense. So let's move ahead and do 6.4. 6.4 says a tangent parallel to CD touches F at P. Determine the coordinates of P. So if it touches, if it's parallel to CD, then it means that M of tangent is also equals to minus 1. And then our question says, let's find the coordinates of P, right? So this is how you do this kind of question. You derivate f of x and then you equate to the gradient, because when you derivate, you find in the slope, right? So we're gonna say f prime x is equals to minus 2x minus 6, and then the 7 is gonna fall off, and this is supposed to be equals to minus 1 because it's the gradient at that point. So we're gonna say minus 2x is equals to minus 1 plus c, right? So we're gonna have x equals to 5 divided by minus 2. Oh my goodness, I don't like dealing with fractions. So now we have x of p, which is 5 divided by minus 2. We can substitute it into our main equation, f of x, right? So we're gonna say f of minus 5 divided by 2 is equals to minus 5 divided by minus 2 squared minus 6 multiplied by minus 5 divided by 2 plus 7. And then let me put that in my calculator and see what that gives me. Just hold on a sec. And that is giving me f of minus 5 divided by 2 is equals to 63 divided by 4, right? And then let's carry on. We have 6.5 that is saying for which values is f of x minus 12 greater than 0. Like I've said, I don't deal with fractions and I don't deal with the graph. I deal with the equations, right? So in place of f of x, I'm gonna put f of x and then I'll solve it algebraically, because I don't want to say, hey, switch the graph, rotate it 360 degrees. I don't want to do any of that stuff. So we're gonna say in place of f of x, we're gonna have minus x squared minus 6x plus 7 minus 12 greater than 0. And then this is what we're gonna solve. We're gonna find the values of x for which this is true. So we're gonna have minus x squared minus 6x plus 7 minus 12. I think that is supposed to be minus 5, right? And then yeah, indeed, so we have minus 5 greater than 0. If we multiply everything by minus 1, we're gonna get x squared plus 6x plus 5 greater than 0. And then okay, now we can say x squared plus 6x plus 5 equals to 0. So here we can see we want our critical values, right? And then okay, if we solve this, I'll explain why I'm doing this. Let's just solve it first. So if we factorize this, we're gonna get x plus 5 multiplied by x plus 1 equals to 0. So x equals to minus 5 or x equals to minus 1. And then we know that our critical values is minus 5 and minus 1. So this is where it gets interesting. So we have two possible answers, right? One of the possible answers is minus 5 and then x, and then we have minus 1. And the other possible values is x being greater than minus 1, or x being less than minus 5. So these are our two possible scenarios. So this is how I advise people to do it, right? We come to the first possible scenario, which says that x is between minus 5 and minus 1, right? And we pick a random number between that range, right? So between minus 5 and minus 1, we have minus 4, minus 3. So let's just take minus 2, right? So if we take minus 2, so if we say f of minus 2 minus 12, right? And then this is greater than 0, then this solution is the one we're going to take. And then if we take minus 2 and then it is not greater than 0, then we're going to take the other possible solution, right? So if I go ahead and do that, I'm going to have minus 2 squared minus 6 multiplied by minus 2 plus 7 minus 12. And then so we're gonna have minus 2 squared, okay, minus 2 squared minus 6 multiplied by minus 2 plus 7 minus 12. And then this is 3, and 3 is greater than 0, right? So our first probable solution is the true one. So we're going to say that x lies between minus 5 and minus 1. If we got a negative value, we're going to know that it's not true. So it's the other possible scenario. So we have 8.1 that says determine f prime of x from first principles if it is given that f of x is equals to minus x squared. And then we're supposed to use first principles. We know that from the first principles, f prime of x is equals to the limit as h tends into 0 of f of x plus h minus f of x divided by h. So now we have our function, we have our formula. We can just go ahead and substitute the function into the formula. So we are going to have the limit as h turns into 0 of everywhere where there is x, we put x plus h because that's what the formula is saying. So we're going to have minus, in place of x, we put x plus h, and then squared minus the formula, the equation, the function itself, that will be minus x squared, right? And then from there, we're going to divide by h, and then we're going to solve x plus h squared, right? So we're going to have the limit as h turned into 0 of minus, if you square x plus h, you're gonna get x squared plus 2xh plus h squared minus minus x squared, which is just gonna be plus x squared, and then divided by h, which will be equals to the limit as h tend into 0 of minus x squared minus 2xh minus h squared plus x squared. So we have minus x squared plus x squared. So that will be 0, right? Divided by h. So this will be equals to the limit as h turns into 0 of minus 2xh minus h squared divided by h. Now we can take h as a common factor, right? So we're going to have the limit as h turn into 0 of h minus 2x minus h divided by h, and then h and h will cancel out, right? And then now we're letting h turn into 0, so we're gonna just have minus 2x. So for 8.1, we're supposed to get minus 2x, which is quite straightforward and easy if you use the power rule. So 8.2.1 says, let's find f prime of x if it is given that f of x is equals to 4x cube minus 5x squared. You can go ahead and use the first principles if you want to waste a bit of time, but you can just use the power rule, right? So what does the power rule essentially say? The power rule says that if you have f of x, which is equals to k multiplied by x to the power n, then f prime of x will be k multiplied by n multiplied by x to the power n minus 1. So if we use that same idea here, we're going to have f prime of x. This is our f of x, right? Which is going to be equals to k is 4, multiplied by n is 3, and then multiplied by x to the power n minus 1, 3 minus 1, and then minus, and then we have 5x squared there. So we're going to have 5 being our k, 2 being our n, and then x to the power n minus 1, which is going to be equals to 12x squared minus 10x, right? And then that's how you do it, easy 2 marks. And then 8.2.2 says find the x of minus, let me just write down that whole thing, divided by x to the power of 4, right? And then what you want to do, you want to write it in our standard format such that you can use the power rule. So if you do that, you're going to have minus 6, that term there, divided by x to the power of 4, plus 2 divided by x to the power of 4. Now we want the x to the power of 4 in the denominator to multiply the numerator, right? So that it can be in standard format and easy to solve. So if we do that, we're going to get minus 6. If you have k and then you have x to the power of p, then this is the same as x to the power of p divided by k. So if we apply the same idea on our term there, we're going to get x to the power 1 divided by 3, right? Multiplied by x to the power minus 4. Because if you take the denominator and you want to sort of make the equation linear, when you multiply it with it, you have to put a negative sign on the exponent, and then we're going to have plus 2 multiplied by x to the minus 4, right? So we're going to have minus 6 minus. So if we multiply in numbers with the same base, we can add the exponents, right? So we have 1 divided by 3 plus minus 4, right? And then let me just do that and see what I get. 1 divided by 3 minus 4, that is x minus 11 divided by 3. And then we have plus 2x minus 4. Now we can derivate using that idea of ours. So we're going to get minus 6 multiplied by minus 11 divided by 3. And multiplied by x to the power minus 11 divided by 3 minus 1. Then we're going to have plus 2 multiplied by minus 4 x to the power minus 4 minus 1. So what is minus 6 multiplied by minus 11 divided by 3? Minus 11 divided by 3. That is giving me 22. And then x. And then what is minus 11 divided by 3 minus 1? That is going to be minus 14 divided by 3. And then minus 8x to the power minus 5. So now we have derivated. Now we just have to take it back to the form that we found it in. So if you do that, you're gonna get 22 divided by x to the power 14 divided by 3. When we go on top, we put a minus. When we come at the bottom, we put a minus again. So because we already have a minus, it will cancel out. And then we have minus 8 divided by x to the power of 5. So in this question, we have a graph f of x, which is said to be equals to x cubed plus ax squared plus bx plus c. And then we have intercepts at m and at some point at 3 and 0, right? And then we have k, which is our y-intercept, and then m and n are turning points. And then the first question, 9.1, it says show that the equation of f, it is given by f of x equals to x cubed minus x squared minus 5x minus 3. But then on the equation we have a, which is unknown, b, which is unknown, and c, which is unknown. So now that we have 3 variables, we usually need 3 equations. So let's see where we can get those 3 equations. We can use point k to get an equation, and then we can use point the other intercept, which is 3 and 0, to get another equation. But then we cannot get a third equation. So this method that we usually use won't work in this scenario. So we have to resort to something else. The other way of solving a quadratic or a cubic function, you can say that f of x is equals to some constant multiplied by x minus x1, x minus x2, and then x minus x3. These 3 points being our intercepts, right? But then in our case, you will realize that we only have 2 intercepts. But then it goes on to say that if we have 2 intercepts, we can have f of x equals to some constant multiplied by x minus x1 squared and then x minus x2. So now the question becomes, which intercepts do we square? We square the intercept that is also the turning point, because for you to have 2 intercepts, you will need 1 intercept to also be a turning point. So if we do that, then we can try and solve our equation. So what we can do, we cannot substitute 3 and 0, because 3 and 0 is at the intercept, right? So we have to substitute any other point. Any other point in this instance is k, which is 0 and minus 3. So if we do that, we're going to get minus 3 equals to our constant. But then what is our constant? Our constant is always this number here. So if this number was 2, then our constant was going to be 2. If it was 1,000, it was going to be 1,000. In this instance, it's 1. So we're just going to go ahead and have 1 there. So we're going to have 1 multiplied by x minus x1. But wait a minute, we know what x is because we're substituting k, right? So here we're going to have 0 minus x1 squared. And then we're going to have 0 minus x2. x2 is 3, right? So we're gonna have 0 minus 3, and then we're gonna have minus 3 equals to x1 squared multiplied by minus 3. If we divide both sides by minus 3, we're gonna get x1 squared equals to 1. Here we're gonna have x1 equals to 1 or x1 equals to minus 1. It's easy to see that m is on the left hand side of the y-axis, so our correct option is minus 1. So we're gonna have f of x is equals to our constant 1 multiplied by x minus x1 which is going to be plus 1 squared multiplied by x minus x2, which is 3. So we're going to have f of x equals to x squared plus 2x plus 1 multiplied by x minus 3. And then if we multiply that 2, we're going to get f of x equals to x cubed minus 3x squared plus 2x squared minus 6x plus x minus 3, which is going to be equal to x cubed minus 2x squared plus 2x squared. That will be plus x squared. Actually, that will, and then minus x squared minus 5x minus 3. So now our a is equals to minus 1, our b is equals to minus 5, and our c is equals to minus 3. And the equation is exactly what we're supposed to show. And then now we can move to 9.2, which says calculate the value of n. N is a turning point, and then what do we know about a turning point? We know that the gradient is 0, right? So we can derive our function and attempt to find n. So if we derive f of x, we're gonna get 3x squared minus 2x minus 5, and then the gradient at tp, we know that is equal to 0. So now if we factorize this, we're gonna find the x coordinate of n, right, and then find y. But then when it's like this, it confuses me. I don't know how to factorize it like this. I have to use the quadratic formula. So I'm gonna say x equals to minus b plus or minus b squared minus 4ac divided by 2a, which is equals to 2 plus b squared, that will be minus 2 squared minus 4, a is 3, c is minus 5, divided by 2a, which is 3. Here we also have a minus. So let me put that in the calculator and see which possible solutions we can have here. So we have 2, let's start with plus, minus 2 squared minus 4 multiplied by 3 multiplied by minus 5 divided by 2 multiplied by 3. So we have x, which is equals to 5 divided by 3, and then we have x, which is equals to minus 1. So okay, n is on the right hand side of the y-axis, so the coordinate for n will be x equals to 5 divided by 3, right? So for n we have 5 divided by 3 and y. Now we can go ahead and determine y. So we're going to have 5 divided by 3 cube minus 5 divided by 3 squared minus 5 multiplied by 5 divided by 3 minus 3, which is giving me minus 256 divided by 27. So it seems like the coordinates for n is 5 divided by 3 and minus 256 divided by 27. So now we can move forward and do 9.3. 9.3.1 for which values of x will f of x be less than 0? Okay, we can see that f of x will be greater than 0 when x is greater than 3. So that tells us that when x is less than 3, f of x will always be less than 0, right? Because look, it's just clear to see. When x is less than 3, it's less than 0. When x is less than 3, it's less than 0, and so on. And then 9.3.2, when will f be increasing? F is increasing when the gradient is positive, right? When we have a gradient that is positive. So we can see that from m going that side, the gradient is positive, right? So from that side to m, the gradient is positive. Another place where the gradient is positive is from n going up, right? So we're going to say that what's the value of x at m? We calculated it to be -1, right? So we're going to say when x is less than -1, it is increasing. And then another point is when x is greater than the x coordinate of n, which is 5 divided by 3. And then 9.3.3 says the values for which f is concave up, right? So what's the point of concavity? If I can say so, the point of inflation is somewhere here between our turning points, right? So if you want to find the x value of the point of inflection, you just sum up the value of the turning points and divide by 2. So we have 5 divided by 3 plus -1. And then if we divide this by 2, we're gonna get the x value of the point of inflection, right? So if I do that, 5 divided by 3 minus 1 divided by 2, I get 1 divided by 3. So concave up. This is concave up, and then this here is concave down. So the graph is concave up when x is greater than 1 divided by 3, clearly. So 9.4 says determine the maximum vertical distance between the graphs of f and f prime. We have already determined f prime, so just to do it again, we know that f of x is equals to x cubed minus x squared minus 5x minus 3, and then f prime x is equals to 3x squared minus 2x minus 5. So when we talk about vertical distance, we're talking about f of some point, right? So we're saying for which value is f of a constant minus f prime of some constant be maximum. That's what we want. We want a point where this is a maximum, right? We subtract the two functions, we derivate the result and equate to 0. And then the value of x, we can then sub it back in to find the vertical distance, right? This is more of like a applied math physics kind of question. So if we do that, we're gonna get x cubed minus x squared minus 5x minus 3 minus 3x squared minus 2x minus 5, and then we're supposed to, so if we do that, we're gonna get x cubed minus 4x squared minus 3x plus 2 equals to 0. So if we derivate this, we're gonna get 3x squared minus 8x minus 3 equals to 0. So I've already told you I don't know how to factorize when it's like this. I always use the quadratic formula. So that will be x equals to minus b plus or minus b squared minus 4ac divided by 2a. And then x equals 3 or x equals to, so I just have to come back here and put a minus, and then x equals to minus 1 divided by 3. So our condition is that the x must be between minus 1 and 0, right? And then clearly this is our option. So what we can do now, we can take this x and substitute it back into our into this expression here.